Welcome to International Conference of Research Advancement, IRA Network 2019, and together with Journal of Advanced Research in Fluid Mechanics and Thermal Sciences, Academia Baru. My name is Muhammad Adrian Thomas. Today, I will present my findings on reconstruction of 3D models in automotive engineering applications using close-range photogrammetry approach. The contents of today's presentation are, I'll begin with the abstract, into the research background, to the proposed method for analysis, to the post-processing, and finally the conclusion. Without further ado, let's begin with the abstract. In this research, the idea is to introduce an alternative solution to conventional methods of geometry generation. The main objective is to propose the photogrammetric measurement system on a car model using a smartphone camera for the data acquisition procedure. The photogrammetric 3D car model is used to investigate the thermal behavior analysis in this research. The results highlight the engine hood panel without the polyethylene form has the highest surface temperature distribution of 347.65 Kelvin, and the panel with PU form covered show the lowest temperature distribution of 264.03 Kelvin. Into the research background, increasing demands for Class A surfaces of body panels in the automotive production are seen as a driving factor. Conventional techniques such as Moore projection, triangulation method, 3D laser scanner, and others have better precision in measurements, but they exhibit numerous major drawbacks. What are photogrammetry methods then? Photogrammetry is an engineering code of practice that has spread by the revolution of computer science. Therefore, the drastic increment in the computer utilization has heavily influenced on the photogrammetry application. The word photogrammetry is derived from three Greek words, which is phon, gamma, and metrin, that denotes as light, drawing, and measurement respectively. The photogrammetry method can be divided into two main groups, which are the far range that branches into aerial and terrestrial techniques, and the close-range photogrammetry method itself. The similarity between the photogrammetry and the conventional methods are they are applicable to all 2D and 3D surfaces. They are very effective to large volumes of data collection, and they are capable to analyze good and bad features of products. However, the difference between both methods are the photogrammetry methods are much more cheaper compared to the conventional methods. The digitizing stages are not tedious, and photogrammetry do not require any extra support system compared to the conventional methods, where the digitizing stages are very tedious and intermediate workstation may be required to aid the process. Also, for photogrammetry, requires shorter time for processing and producing 3D models compared to the conventional methods. Thus, the advantages of using the photogrammetry methods are it is inexpensive, fast, and efficient as well. It can also be utilized in certain areas that are hazardous and troublesome to reach or investigate. And the photogrammetry methods are applicable to most industrial platforms. In this research, the close-range photogrammetry method is used to obtain images of the car demonstrator. Mirrors are covered with lime shields to hinder any reflective surfaces. This is because the photogrammetry method does not work effectively with reflection. Circular marking of 5 degrees measured from the center model of the car model is performed. This is to increase the overlapping images of the car demonstrator to enhance the photogrammetry model. Also, tripod stand is used to avoid any shakiness during the photogrammetry procedure. This is to avoid the pictures from being blobby. Also, the images are acquired from 3 different rows, which is from the top, middle, and the bottom row. This is also to increase the overlapping images for enhanced and precise 3D model generation. Initially, poor visualization and model reconstruction with very low consistencies are seen. This is because the photogrammetric model failed to derive most of the collected data from those images. This is because of the shiny and reflective surfaces of the car body panels. Thus, it causes geometric distortion during the digitizing phases. The dashed circled in the figure show the region of the deformities of the reconstructed 3D model. Therefore, the body panel of the car demonstrator is modified using the polyethylene form, as shown in this figure. After the modification is made, similar photogrammetric procedure is performed, and the new reconstructed 3D car model has higher geometrical consistency. improved rendering performances with sharper visualization and better efficiency in terms of surface recognition. As I mentioned before, this study focuses on how to develop a 3D car model using the photogrammetry technique to aid to provide solid geometric body for thermal model for the following thermal study purposes in this research. In the study, heat transfer by means of radiation, conduction, and convection of the engine hood panel are investigated by assuming the car is traveling at about 50 meters per second, and the geometry and the frontal design of the car is not taken into consideration. The heat transfer by radiation occurs when the heat is dissipated from the running engine to the surface below of the hood panel. The heat gain is then transferred through microscopic collision of particles or conduction across the length of the panel's thickness towards the inner surface of the polyethylene film, and finally transferred by forced convection. Two types of thermal investigation are performed, which are the panel surface without the polyethylene film and the other with the polyethylene film covered. This is a figure for the panel surface without the polyethylene film. The thermal simulation have shown that the hood panel without the polyethylene film has the highest temperature distribution, which is 347.65 Kelvin. This is because most of the hood panels are made with cold drawn steel. This material has high heat conducting properties with very low heat. Where polymer, the polyethylene film is a polymer where it has very low heat conductivity. Therefore, the rate of heat conduction in the first case of the hood panel without the PU film is greatly higher. The following investigation is performed for the hood panel covered with the PU film. In this case, the maximum temperature shown by the software is about 294.03 Kelvin or 21.03 degrees Celsius. In depth, the PU film contain abundant tiny and large air gaps or voids in their structure. These air gaps reduces the heat transfer by conduction and thus resulting a lower rate of heat conductivity across the material. This has significantly influences the temperature distribution of the interface between the two outer face of the hood panel and the PU film. Therefore, the heat quantity on the surface above the panel at point T2 is transferred slowly across the PU film to the outer surface of the PU film. Moreover, heat transferred by means of forced convection is also considered in both of these simulation analyses. As a conclusion, the interrelationship between the photogrammetry technique and automotive studies have been proven to be very advantageous in the study. This is a preliminary study, and further investigation on several cases can be done involving the thermal elements. The use of photogrammetry technique is to create a 3D model of the sedan car, beforehand used as a thermal model to run the following thermal simulation. This simulation, illustrated by the thermal car model in the study, are satisfactory and theoretically intact. The data obtained showed the photogrammetry technique could be used to perform several other investigations. The current method has managed to obtain great improvement over the previous study with only minimal adjustment to the technique. Also, regarding on the foregoing future work, improvement can be made by controlling the light system around the object and further preparation on the vehicle surface to improve the accuracy of the model. Thank you very much.